You know, when you put on a t-shirt, have you ever really thought about what's going on there? I mean, beyond just getting dressed. Because there's this entire world of hidden science woven into the very fabric of our clothes, and it controls everything, from how strong they are to how they feel against your skin. So let's unravel that science, starting with a question we've all wondered about.
Think about it. You know that feeling, right? The incredible smoothness of a silk scarf versus, say, the rough, tough feel of your favorite pair of jeans. What is actually going on there at a physical level? Why do some clothes feel so luxurious and others feel so, well, rugged?
Believe it or not, the answer is a force we usually think about with things like stopping a car or rubbing our hands together to get warm. That's right, it's friction. Friction is the secret architect behind the feel of every fabric you've ever touched.
Okay, so to really understand how this all works, we need to zoom in. I mean, way in, down to the microscopic level of a single fiber. So, what is friction? Well, put simply, it's just the resistance you get when two surfaces try to slide past each other. For our clothes, we're talking about millions and millions of tiny little surfaces, the individual fibers themselves, all interacting and rubbing together. And as it turns out, there's more than one kind of friction at play.
There are really two main types we need to care about here. First, there's static friction. Think of this as the initial stickiness you have to overcome to get something moving in the first place. Then you've got kinetic friction. That's the resistance you feel once something is already sliding. And that difference between the two, that is exactly what makes a fabric feel either smooth and slick or rough and grippy.
Now, we almost always think of friction as a bad thing, right? Something that slows us down, that we want to reduce. But in the world of textiles, friction is actually the unsung hero of the whole story. It's absolutely essential.
I mean, let's be clear. Without friction, you couldn't even make yarn. Your clothes would literally fall apart into a pile of fluff. It's that frictional grip between every single fiber that lets them be twisted together to form a strong, solid thread. Friction is what holds it all together, from keeping the tension just right during manufacturing to even making the yarn look shiny. Without it, you can't make fabric, period.
And this is where it gets really cool. Check out this wool fiber. It's covered in these tiny microscopic scales, all pointing in one direction, kind of like tiles on a roof. This means that friction is way stronger if you move against the scales than with them. It's like petting a cat, you know, smooth one way, rough the other. It's called the directional frictional effect, and it is a totally brilliant piece of natural engineering.
But you know, for every hero, there's a dark side. And if friction isn't kept perfectly in check, our hero can very quickly become the villain of the story.
See, too much friction is an absolute disaster in a textile mill. It makes yarn snap left and right, it wears down incredibly expensive machinery, it creates all these little defects in the fabric like tiny knots called neps or just a general fuzziness. Oh, and it also generates static electricity, which is basically a magnet for dirt and dust, making the final product look grubby. And we're not talking about a small problem here. To put it in perspective, high static friction, that initial stickiness we talked about, can be the cause of more than half of all yarn breakages during the super high-speed weaving process. That is a staggering amount of waste and lost production, all because of this one invisible force.
So, if friction is both this necessary hero and this potential villain, what do? Well, you learn how to tame it. And textile engineers have gotten incredibly good at taming this force with unbelievable precision.
They have a whole toolkit for this, but it really boils down to three main strategies. They apply special lubricants, they use chemical treatments to change the surface of the fiber itself, and they use all sorts of finishing processes to smooth out the final fabric.
So let's talk about lubricants, because it's pretty clever. The idea is simple. You coat the fibers with a super thin layer of something like an oil or a wax. This layer acts like a tiny molecular cushion, keeping the rough surfaces of the fibers from snagging on each other, so they can just glide right past. And this is the part that's so fascinating, it's not as simple as more is better. It's actually the opposite. This graph shows it perfectly. If you add too much lubricant, or you use an oil that's too thick, it can actually make things stickier and increase the friction. It is all about finding that perfect, razor-thin sweet spot. And it's not just about lubricants. Engineers are like DJs at a giant mixing board, tweaking all these different variables. For instance, cranking up the temperature or letting the fibers absorb more moisture can make them slide more easily. On the flip side, using heavier fibers or increasing how much they touch each other will pump up the frictional grip. It's an incredibly complex balancing act.
So as you can probably see, the real story of our clothes isn't about trying to get rid of friction. It's about achieving the perfect, beautiful balance.
There's this quote from the research that just sums it up perfectly. Too high friction and too low friction is not good for yarn. You need just enough to hold everything together, but not so much that it tears itself apart on the way. It's this constant negotiation with a fundamental force of physics.
And really, that's the bottom line. Every single piece of fabric you own, how soft it feels, how strong it is, even how it catches the light, is a direct result of engineers finding and locking in that perfect, delicate balance of friction.
So the next time you pull on your favorite sweater, maybe you'll feel it a little differently. Maybe you'll take a second to think about all that invisible engineering in every single thread, that perfect balance of friction that's holding it all together for you.